Damos inicio técnico a nuestro evento y invitamos a la apertura técnica del evento a la señora Débora Barry. Ella es coordinadora regional para Centroamérica de la Iniciativa Global del Agua, Agua Verde, y un poco de su biografía. Débora Barry es especialista en Geografía Económica y Cultural de la Universidad de California, Berkeley, y tiene su maestría del Centro de Investigaciones Superiores en Antropología Social de México.
Muy buenos días a todos y todas que han venido a estar con nosotros. En nombre de la Iniciativa Global del Agua, de Catholic Relief Service, o CRS, como se conoce con cariño, les doy la muy bienvenida de parte de nosotros. Quiero decir que después de la ministra es difícil hablar, porque la verdad es que yo creo que cubrió los puntos más importantes que compartimos aquí en el país de El Salvador y esperamos también a nivel de la región centroamericana. Y más allá, yo quiero mencionar que la invitación para el evento, casi 100 de ustedes, 100 personas, 97 por ahí, ha venido desde afuera para estar con nosotros. Y queremos agradecerles todas estas 100 personas que han venido de lejos y de América Latina, también de Centroamérica, para estar aquí a compartir esos 2 días. Tenemos un nivel de capacidad, de excelencia en nivel de los ponentes que es realmente notable. Pero también en el público es lo mismo. Yo diría que las otras 100 personas que han venido aquí localmente, que o son salvadoreños o viven en el país, tienen un nivel muy alto de conocimiento de los mismos temas que vamos a tocar en estos días. Entonces, lo que hemos tratado de hacer es lograr un evento donde puede haber mucha participación entre ponentes y el público. Y cuidado que el público se puede convertir en ponente. Eso es lo que queremos realmente. Para lo mismo, diseñamos los coffee breaks o los recesos de media hora. Eso es a propósito para que se comiencen a conocer entre ustedes mismos y ayuda de aumentar la capacidad de este mismo grupo de incidir en las políticas públicas, como mencionó la ministra de Medio Ambiente, pero aquí sí a nivel de Centroamérica. Eso es uno de los objetivos del evento. Ha sido parte del proceso de organización del mismo. Tengo que decir que ayer fue muy alentadora ver los grupos de los panelistas y otros discutiendo. Había uno ahí sobre extensión que discutió fuertemente durante 3 horas lo que iban a proponer este día. Entonces yo creo que va a ser un encuentro realmente algo eléctrico, pero también muy fructífero. Quiero mencionar que la preocupación de la iniciativa del Global del Agua está enfocando, como dice el título del evento, en revitalizar la inversión en el agua, en la agricultura de secano o la agricultura de agua de lluvia. Pero nuestro enfoque principal es en la agricultura familiar. Creemos que es, ojalá, el intento de agregar a los esfuerzos para el año de agricultura familiar 2014 que han hecho otros como la FAO y EICA, recientemente celebrado aquí en San Salvador la semana pasada. Nuestro enfoque es un complemento y nos pide que enfocamos en cómo hacemos la agricultura. Como mencionó la ministra, ya no podemos seguir haciendo lo mismo. No hay tiempo para ser pesimista. No se puede seguir degradando. 3/4 del país en el caso de El Salvador, casi 50% en el caso de Honduras y similar en lo demás de la región. Nos urge abrir la mente y volver a la tierra, a entender de que los agroecosistemas son los que nos sustentan la producción y la productividad. Y por último quiero mencionar que el enfoque del evento tiene un hilo conductor sobre cómo el agua el agua de lluvia, no el agua de los ríos, de los charcos, de los lagos, ni los barriles que llamamos el agua azul, sino agua de lluvia en su sistema natural hidrológico puede ser el factor principal en aumentar la productividad y garantizar la producción que necesitamos en esta región. Para todos, en la gran producción agrícola, pero también y sobre todo para nosotros en la agricultura familiar. Con esto abro la noción de que cuando salen de aquí esperamos que todo el mundo por lo menos comprende mínimamente lo que entendemos por agua verde, que no es un agua chuco con musgo flotando encima, como mucha gente cree, sino el mismo agua de lluvia en su ciclo natural, que estamos utilizando por debajo del 50% de su productividad. Lo que vamos a lograr ahorita es entender cómo esto es una reflexión a nivel mundial con estudios muy recientes que van a ser traídos aquí a la mesa en la persona de Jennie Barron, que sería la primera expositora. Por lo demás, les agradezco de nuevo y cualquier cosa estamos a la orden. Esperamos que estén con nosotros todo lo que pueden durante los próximos días. Muchísimas gracias.
Vamos a invitar a la doctora Jennie Barron a dictar la conferencia magistral Agua Verde para la agricultura de secano, el nuevo reto para esta década. La doctora Jennie Barron es investigadora senior en agricultura y gestión del agua para el Instituto de Medio Ambiente de Estocolmo y está afiliada al Centro de Resiliencia de Estocolmo. Cuenta con más de 15 años de experiencia en gestión de agua e investigación relacionada a este tema. Ha trabajado en el África subsahariana, el sudeste de Asia y Australia. Y además ofrece como experta y consultora internacional su experiencia para diversos organismos internacionales en materia de investigación y desarrollo. En estos momentos invitamos a la doctora Jennie Barron a pasar al podio.
Good morning, dear distinguished guests, ministers, ex-ministers, colleagues and organizers. Thank you for having me here today. It's a great pleasure to be here, and I will take a much more global perspective than we just heard from our previous speakers, and to try to set the context on how green water can make a difference and contribute to well-being and sustainability in a world which is increasingly under pressure. I will try to bring some of the key points and experiences from some of the cases I've been working on, and hopefully that will also stimulate the debate and raise more questions and interesting comments in the context of the context that we are in here today in Central America. There are two things that makes it very timely to address green water right now, both at the global and, of course, at the local scales. And firstly, the pressures on our water and land resources are decreasing the capacity to provide income and benefits. It's our ecosystems, and particularly our water, is increasingly scarce and may not be able to cope with more pressures for development, both in quantity and quality. And secondly, there's an emerging set and a lot of knowledge to tell us where the opportunities to lever the benefits using green water approaches and develop the income and food security and ecosystem health, both at the local and eventually, hopefully, at the global scale as well. My talk here today will cover three main sections, and I will talk a little bit about the global problems, the issues and the pressures that we are experiencing, and the importance for green water management, and the opportunity, and trying to show some examples from other parts of the world where we know green water management had made a difference. And thirdly, I will try to bring some of the issues that we need to solve immediately if we're going to realize the green water management opportunities that might be available for us today. The first thing I would like to say to clarify when I talk about green water, Deborah was referring to green water as the rainfall. We have to manage the rainfall to make sure we make the best use of it in our landscapes. Green water is then eventually the soil moisture that we manage for the benefit of biomass production. And this is a hydrological reference to the water, to green water. And when I refer to blue water, I roughly mean the liquid fresh water in streams, lakes, and the groundwater sources. One of the most pressing issues on the global level, or even more so at specific local and national scales, like we just heard about, is the increasing demand for blue water for development. We estimate that we're reaching about 4,000 cubic kilometers a year now, and we have about a rough planetary boundary around 6 to 7 cubic kilometers of blue water appropriation. And most of this is used for irrigation supply and therefore consumptive with little use and benefit downstream. This withdrawal is very costly in terms of infrastructure, but it's also decreasing in supply, and therefore we have to find other alternative solutions to supply our water for our crops and biomass production. A particular water-consuming concern is, of course, the demand for food. And we know that water appropriation for food and fodder to supply various diets are very different. A great concern is the estimated needed to more than double current food supply to 2030 or 2050 and for the global population. But it's not just about a population growth, but it's a diet shift that is the critical thing here. And as you see here in this graph, which see in 2005, we have about 2.3 billion people in the dark green brackets. I can see if I can use a pointer. Here, the dark green brackets that are consuming about 2,500 to 2,700 or even more kilocalories a day per capita. And what is happening in 2050 is that we have about 6 billion people in this bracket of diets, which is very water consuming to produce and to feed that demand. As we heard by the minister referring to the conditions here in El Salvador, the increase of droughts and climatic and other catastrophic events are seriously hampering our capacity to provide food, fodder, and biomass for different benefits. And here we see a graph that we see, especially the flood events with severe impacts on infrastructure, food and food production has increased globally over the last 30 years. IPCC recently released another report which should make us even more worried, because the figures are showing increased of droughts and dry spells, especially in those areas which are key for our food supply at the global level. In North America, in parts of East and Central Africa, Australia, as well as in parts of South America, which are critical to provide the food we need to sustain our livelihoods, both at global and local level. These multiple processes of change for population, development, climate are increasingly impacting beyond the local context, and we suggest that there are emerging critical tipping points, and the minister talked about sustainability and resilience, which is the inverse in some cases of tipping points. In tipping points in our water resources as well as our land resources, and to the left here we are mapped some of the evidence on water-related, blue water-related tipping points points, which critically can hamper our opportunities in agriculture productions. And on the right-hand side, I think it's equally important to recognize the emerging land-related tipping points where green water might actually present to be a real opportunity to ensure that we're not going over those tipping points and can make us sustain the resource base in those particular areas. All in all, these changes and developments have led to fundamental shifts on our hydrological global model. And here we map them as green and blue flows from different types of land use. On the left-hand side, you see a sort of natural pre-industrial set of green and blue flows. And on the right-hand side, we have mapped out what are the anthropogenic or the human impacts of diverting flows and appropriate flows for our food production. And keeping in mind that we have to more than double our food production until 2050, I think we can expect these arrows to change even more. So this was a grim picture, but I hope that we can also find some of the opportunities. And I would like to show that although on the global scale we have a very grim picture, I think at the local scale we're finding more and more evidence and knowledge and cases that things can be turned around into positive trajectories. As you know, and you might have seen this map before, this is showing how water is used, what type of water, green or blue, that sustains our food production systems in different regions of the world. And this map was done nearly 10 years ago, and it's only including food. And we should recognize that fiber and fodder are key things that we also produce, and that also are sustained by green or blue water. Essentially, most of our food in the world is produced by green water, and it's produced by smallholder farmers in those regions. What is more important for green water management is to look at the opportunities. And this map shows the yield gap between what is possible to attain and what is on average being produced at a certain location around the world. And there are two things here that are very important in my mind, and that is that we have large yield gaps, the orange and the yellow colors on the map, and therefore opportunity to increase the current levels of production significantly in parts of sub-Saharan Africa, Central America, and Central and Southeast of Asia. And the second point I would like to make here is that these areas with high yield gap correspond to areas of current high green water reliance, which you saw on the previous slide. The opportunity may actually lie in the green water realm for substantial parts of the areas to close the yield gaps. There is a vast source of knowledge on how to address yield gaps with green water management in rain-fed systems. And this is an example from the semi-arid region of Southern Africa, where we have collected more than 1,000 references of research comparing conventional yield with improved rain-fed systems. For example, nutrient management, in situ water retention, reduced tillage, and more complex interventions such as water harvesting and storage, intercropping and agroforestry, or combination of nutrient and water management systems. And what you see from these paired examples of more than 1,000 cases is that you can substantially increase the current yield levels of 50 to even more, up to 500% in some cases. And again, I have two key points that I would like to make here. And the first one is that the combined technologies where you combine water and nutrient management, agroforestry or mixed cropping systems show a higher yield potential than single technology interventions alone. And this is key points for the development agents, extension service and farmers. We cannot work on single technology interventions anymore. Secondly, The variance of each class, the outliers, these are the opportunities for us researchers to explore further. What happened in these cases where you improve the yield 400 times or 200 times the conventional system? And how do we make sure that these examples are outscaled, as the minister was talking earlier, and taken up to scale among smallholder farming systems in particular? At the watershed scale, which is my favorite area of working, our landscapes are changing extremely quickly, often with increased degradation. This is an example from semi-arid West Africa, Burkina Faso, and these maps show that large change from savanna in 1955 at the top. So a savanna landscape, 1955, with 20% agricultural land. And 2010, we have 80% agricultural rain-fed land in this semi-arid watershed. What is interesting, though, this is an area of 1,000 square kilometers. What is interesting is that the water balance is quite stable. The green water flow leaving the landscape is still 90% of the annual rainfall, and the partitioning between runoff and infiltration is so little between the two very different land use systems that we cannot really say with certainty that there has been a significant change. To me, what is even more interesting is that in 1955, we had a much higher biomass production for the green water loss than we have today in the low-yielding agricultural system by smallholder farming. I think there is the real opportunity to maximize the green water flow for the benefit of people. A similar example from India semi-arid watershed has actually a more positive spin. And through implementing water harvesting structures in fields and streams, it has increased farmers' income. By enhancing water available in the root zone, so the soil moisture, the green water, through the interventions, a shift was made from sorghum in the degraded landscape to cotton in the improved landscape. And this enabled farmers to increase their income significantly. And these are the kind of cases and examples that we need to have and discuss when we go forward in trying to understand what we can do with green water management in the best possible scenarios. I should also say that this intervention actually had a very little impact, except in the dry years for downstream users of water. And the benefit that was accumulated to the upstream rural farmers was much higher than the water downstream used for Hyderabad domestic supply. Finally, it's critical to show also how improved landscapes for production can be sustainable. And we talk about resilience for the future and for future change. And this modeling study from a semi-arid Brazil landscape, which has had a rapid change again from agriculture over the last 100 years. Again, you see about 80% of the catchment, about 1,000 square kilometers, being under agriculture today, has improved its carbon stock significantly. So now the carbon stock in the landscape is modeled to be 80% of the initial natural landscape. And this is the kind of sustainability dimensions that we also have to take into account when our agricultural landscapes develop. The future. How can we leverage the change in green water management? So if we have this knowledge, both global and local, what can we do to make it happen to scale? And I think this is not a $1 million question, but quite a $1 billion question. And I think that the minister again showed the way much better than I had any idea because I don't work in this region. I think that there's a real opportunity now in terms of policy consensus. Increasing the policy context cannot no longer be used as an excuse, as being a barrier for sustainable development or agriculture development. Everybody are signing up to sustainable development, green growth and environmental consensus. The new sustainable development goals coming in 2015 will guide development for public and private actors and agendas to come. And they are far more comprehensive than the Millennium Development Goals in terms of poverty, hunger, the environment, food production, and not the least water resources. So we have something to lean on when we try to justify our business case. More specifically, on the integrated water resource management discourse, there's a much better understanding for accounting for all water flows in the management and governance documents these days. And we can see a development where this trajectory is starting around 1990 and going up to today, where we now see countries and IWRM documents containing emphasis also on the soil moisture part of the cycles for governance to take into action. Thirdly, the water resource scarcity, especially competing interest for the blue water, makes it more beneficiary to maximize benefits from green water than costly blue water interventions. And the business case is still to be developed better by researchers as well as practitioners, but I think the case is there, and we need to get those numbers to the policymakers and investors to understand why it's cheaper to develop green water resources than sometimes develop very costly blue water infrastructure. Finally, we're slowly starting to understand and find evidence also how green water management and rain-fed agriculture and what the triggers are to capitalize on opportunities. More and more cases, like my own stories, emerge from how actual real benefits as in income make fundamental difference for farmers to invest into improved soil and water practices, and especially rain-fed green water management. I have some stories on fodder, cotton, tobacco, grains for beer, as well as fruits from agroforestry from different countries and farmers. But from this region, I just heard yesterday about high-grade coffee and cocoa. And there are also examples on compensation schemes, for example, sustaining or improving particular ecosystem services that can work, including carbon credits. Knowing that secure income is there can justify investments back into the enterprise, creating positive feedbacks into the system. But we still need to understand this much better. How many farmers and how much income and how quick is this able to retain these feedback and reinvestments back into the enterprise, able to build the land and water capacity in degraded states? These evidence are not yet systematic or coherent, or to convince investments to scale that might be needed. We do not know to ensure which set of actors are best bet to take this forward, and which constellations, together with farmers, can reduce transaction costs or safeguard, especially smallholder farmers' negotiating abilities in these ventures. But they are there, and they appear to accelerate uptake of best practices in green water management for smallholder farmers. Some conclusions. We do want to move away from this type of soil. My first point would be that pressures on our soil and water resources provide the opportunities and challenges to realize the water smart or green water managed agriculture. And the best bet opportunities is in the current low-yielding agroecological systems where yield gaps are high. We know the knowledge how to address this, and the environmental sustainability gains can be made. And our joint global and local knowledge, together with the current policy, the private sector, and including farmers, need to collaborate to enable these smallholder farmers' opportunities in green water management. So the title of this introductory talk that I was actually given by the organizers was Green Water or Water Smart Agriculture, a new challenge for this decade. I would like to change it and say that it's a new opportunity for this decade. And with these small points, I thank you for having me here today, and I sincerely look forward to the following sessions with more contextualized discussions and questions and answers on how to move ahead. Thank you very much. Gracias.